What if you could find the perfect grant in 10 minutes instead of 10 hours? For most researchers, funding is an 8,000 opportunity nightmare. If you've felt that burnout, you aren't alone, and standard AI isn't saving you. We've all tried LLMs, but naive AI fails when the stakes are high. It hallucinates and misses the nuances of the academic landscape. Relying on a monolithic model is a recipe for frustration. We're breaking down the grant problem and introducing a game changer, compound AI systems. I'll show you how a dual-layer solution, integrating multiple specialized components, solves tasks a single model can't touch. The future of research isn't just more AI, it's smarter architecture. If you're ready to start winning more funding, let's get into the mechanics of compound AI.
Hey everyone, welcome to The Explainer. Today, we're diving into a problem that literally plagues the academic and research world. If you've ever had to hunt down funding for a research project, you know exactly the kind of pain I'm talking about. It's tedious, right? Well, we are going to look at some truly fascinating new research that drastically speeds up this agonizing process of finding research funding. Okay, let's jump right in. Just imagine this for a second. What if securing your next major research grant took 10 minutes instead of an hour? Think about how much time you or researchers you know spend just hunting for the right grant, digging through clunky websites, trying to figure out if you even qualify. It's a lot. What if we could shrink that massive time sink down to basically the length of a coffee break? Well, that is exactly the promise of the system we are exploring today.
Section 1. The Grant Discovery Problem, a Fragmented Landscape.
To really understand the core struggle academics face, we have to look at the reality of the funding landscape today. Right now, a typical manual search across fragmented portals, places like grants.gov, NSF Fastlane, or NIH Reporter, consumes about 30 to 45 frustrating minutes of a researcher's time. And get this, that's just for one single search session. You have to juggle multiple interfaces, none of these systems talk to each other, and most of them have absolutely zero AI support to help you gather insights efficiently. It's cognitively demanding, and honestly, it's a huge bottleneck to innovation. And when you map out the distribution of these funding opportunities across the US, you start to see why it takes so long. It is basically pure chaos. You have a staggering 8,696 foundation opportunities out there, then you have hundreds more scattered across the NIH, the NSF, the Department of Defense, and so on. Every single one of these agencies has its own distinct search interface, totally different data schemas, and unique terminology. You essentially have to learn a completely new language for every single database you want to search. Section 2. Why general AI fails. Limitations of naive LLMs. Now, knowing what a fragmented mess the landscape is, your first thought is probably the modern shortcut, right? I'll just ask ChatGPT. But here is exactly why we have to contrast a naive large language model approach with a highly structured unified index. A general off-the-shelf LLM is absolutely incredible for drafting or refining your proposal writing. But when it comes to finding factual, hyper-specific grant data, it completely falls flat. General LLMs can't easily penetrate those deep, fragmented agency databases we were just talking about. And honestly, what's worse is that they want to please you so badly that they will actually hallucinate fake grants or surface opportunities that expired 3 years ago. What researchers actually need is a structured, factual index that grounds the AI in reality. So the crucial takeaway here is this. Without domain-specific support and a unified schema, a naive AI is going to introduce factual errors that could waste a grant writer's time even further. Just imagine spending hours writing a brilliant proposal for an AI-generated grant that literally does not exist. Or, finding out you poured your heart into an application, but the deadline passed a month ago. Because general AI lacks a unified grounding index, it's totally unreliable for the high-stakes world of research funding. Section 3. Enter compound AI, a dual-layer solution. To fix these AI blind spots, we need a totally new approach. We should define this concept because it is a real game changer. A compound AI system is a design that integrates multiple components working in sequence or parallel to solve a complex task, rather than relying on a single monolithic model. So this isn't just one giant chatbot trying to do everything at once. It's a pipeline. It combines structured data pipelines, retrieval modules, and language models so they can achieve much higher accuracy and completely avoid those common pitfalls like hallucination and stale data. Think of this compound approach as having two distinct layers working together. The first is the continuous aggregation layer. This is essentially the workhorse of the system. It continuously gathers data from all those disparate agency websites and parses it into one neat, unified schema. Then you have the agentic query processing layer. This is the brain that you, the user, actually talk to, and it pulls information exclusively from that pristine, unified database. By separating the indexing layer from the query layer, the system gets the best of both worlds. It has perfectly fresh factual data combined with advanced natural language understanding.
Section 4. How the agent works. Avoiding hallucinations.
Let's peel back the curtain a little deeper on the mechanics to see exactly how this works in practice. The aggregation process happens in 3 distinct steps. First, the system deploys LLM-equipped browser agents and uses tools like Firecrawl to autonomously scrape those heterogeneous agency sites. Second, instead of using brittle extraction rules that break whenever a website updates, it uses a language model to parse that raw, messy HTML into a clean, normalized schema, meaning it precisely extracts the title, the description, the URL, and the deadline. And third, it pushes all of this into a unified index containing roughly 11.8 thousand opportunities. It does this bi-weekly, which turns out to be the perfect balance between keeping the data fresh and managing computational costs. So once all that pristine data is stored, how does the agent actually find what you're looking for? It uses something called a React-based framework. The agent has explicit decision logic and is equipped with 2 very specific tools, search index and web search. When you ask it a question, it first checks that factual 11.8K database using the search index tool. This guarantees the results you get are verified and real. But, and here's where it gets clever, if the agent realizes you're looking for something that was just announced yesterday, it dynamically invokes the web search tool to find complementary, hyper-recent results. It literally decides on its own which tool to use to get you the most accurate answer. But honestly, the user experience is where this gets really amazing. You don't even have to type out complex search Boolean operators anymore. A researcher working on, say, climate-adapted agriculture can literally just upload a full PDF of their grant proposal draft directly into the chat. The agent automatically reads the context, extracts the highly specific, domain-relevant keywords without any manual guessing from the user, and searches the index. From there, you can just chat with it naturally, iteratively applying constraints like, hey, which of these have deadlines more than 6 months away? And this level of transparency is a massive part of why this system is so effective. As highlighted by the researchers, interface design that exposes system reasoning and intermediate results can calibrate user trust and reduce over-reliance. They specifically designed this to reveal the black box of AI. As the agent extracts keywords and ranks the results, it actually streams its reasoning live to the user in real time. Because you can instantly see exactly why specific opportunities were retrieved, you develop a much deeper trust in the system, and crucially, you also understand its limitations.
Section 5. Real-world results. Performance in the wild.
It all sounds great in theory, right? But let's see how this actually performs against standard methods. If you compare a standard web search for grants, say at the intersection of LLMs and healthcare, against this compound AI system, the difference is night and day. A standard search engine gives you a mess of news articles, fragmented agency portals, and just a lot of irrelevant hits. But the compound AI system? It provides precise, structured metadata. You get the exact grant title, the agency, a concise summary of what it actually funds, and direct, verifiable hyperlinks straight to the official pages. And that brings us to the ultimate victory of this research. By moving away from that fragmented keyword guessing game and shifting to a unified, conversational, and iterative flow, the system takes that agonizing 30 to 45-minute search process and slashes it down to under 10 minutes. It fundamentally removes the friction from funding discovery, giving researchers their time back. The coolest part? This isn't just theoretical computer science happening in a lab. This platform has already been deployed in the real world. It's actually live right now at grail.page, and it is actively serving over 3,000 researchers. That completely validates that compound AI is a highly practical, scalable solution to incredibly frustrating real-world data problems. So I want to leave you with a bit of a provocative thought. We've just seen how a dual-layer, hallucination-free AI architecture can perfectly index and search the chaotic world of research grants. But let's think bigger. What other massively fragmented industries out there, law, healthcare, real estate, supply chain logistics, could be completely revolutionized by this exact kind of transparent, compound AI? The blueprint is out there now, and honestly, the possibilities are pretty endless. Thanks for learning with me today, and keep exploring.